Welcome to Emilak Online Tutorial. Now before us is this A-level question in elasticity, and we are told that a spiral spring of natural length 20 cm has a scale pan hanging freely in its lower end. When an object of mass 40 grams is placed in the pan, its length becomes 21.80 cm. When another object of mass 60 grams is placed in the pan, the length becomes 22.05 cm. Now calculate the mass of the pan. Now let me give you a pictorial illustration of this. Now let us assume that this is the spring. Now, and a pan hangs on it. Let us assume this is the okay. All right. Now, and by this is the length, which is 20.0 centimeter. Now, when a mass of 40, now let us assume that a mass of 40, okay, when a mass of 40 is being hung here, mass of 40, now there is always an extension. Let us assume that the extension comes this way, and this is the mass itself, that is the 40. So there's an extension from here, let me see, from here to here, okay. All right, and that extension here is 1.80, okay. Now, and another mass of 60 was hanged, and that was definitely, that would be another extension. And this one is 60, so there will be another extension towards this hand, okay. So this is another extension, which is that will be 2.05. And how do I get this? Now this is the original length. You know that extension equals to the new length minus the original length, and the new length here is 21.08, then minus 20.00. This will give us 1.8, and that is for this. Now the second one, which is L1 minus L, that will be the same. Here you have 22.05, then minus 20.00, and this will give us 2.05, and that was how I got. Now you can see that the extension here is proportional to the mass, okay. Now from here, let's assume that here without the mass, let me say, okay, this is 40 grams here. Now without the mass here, we have this m, okay. Now with this mass, now there's now an increase. Now this will now be, let us say m will now be the mass of the pan plus this mass, okay. Let's represent m as the mass of the pan. Now this one also will now be m, let us say this is m2, this is m1, okay, and this is m2, which will now give us the mass of the pan plus this this other mass here, okay. Let me say this is 60 for 60, and this one is 40, okay. Now we can see that the extension of this length now is proportional to the mass, right? So, and if this is true, so we can say here that the M1, right, is proportional to what? E1. So proportional to E1, and M2 is equals to what? E2. Now this is because, now let us realize that M is proportional to E. Take note, and the constant between them is K. Alright, and that is the elasticity constant. And to this end, now we can say M1 all over E1 equals M2 all over E2. Now if this is true, we can now plug in this parameter. Now for M1, you can say this is capital M plus, that is the mass of the pan, plus 40 all over the extension here is 1.80, then equals to M2 plus 60 all over 2.05. okay, now if we should cross multiply, here we have that will be 2.05 m now plus now 40 times 2.05, so give us 82, then equals 1.80 capital M plus now 60 times 1.80 give us 108. Now let us collect like them. We now have 2.05 capital M, then minus 1.80 M, then equals 108 minus 82. Alright, so 2.05 minus 1.8 give us, now this is 0.25 m equals 108 minus 82. This will give us 26. Now, and if we divide both sides, making m the square root of relation, you have 26 all over 0.25, and when we do that, when we divide through, here we have that the mass equals 104 gram. Okay, so the mass of the pan is 104 gram. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Thank you and God bless you.